No. Okay, there we go. So, hello everyone. Hi. You've totally never seen me up here before, right? All right. So hi, I'm Beej, one of the organizers. Today we'll do a very brief 30-minute workshop on intro to Git and GitHub. And Andre, you're good? You don't see me on camera. Okay, 1 second while we troubleshoot some AV stuff. All right, sorry, we're having a bit of technical difficulties, but we are good now. All right, so intro to Git and GitHub. Now, before we get started, I want to manage expectations. We are going to go fast. We only have 30 minutes. Usually when I do this, I take 2 hours, so be ready. It's going to probably be less entertaining than usual. I'm not going to cover as much theory, so you're not going to have a full, complete understanding of how these systems work, just knowing what you need to get done. There won't be an interactive portion. Normally we do kind of a back and forth, we walk around, we help people. We will not have that. And we're only going to focus on the parts you're likely to use, not the whole thing. And lastly, we are recording the stream. We will share the recording online a short time after it's finished, and you can use that as a reference if you need later. All good? All right, so diving in. 28 minutes left, here we go. So we're gonna go over why you would want to use Git and why you would want to use GitHub. Otherwise you're gonna be like, I don't know what I'm doing or why I'm doing it. Then we'll cover briefly how Git works, because you do need to understand some of the different pieces in order to use it properly. Then we'll walk you through setting up your own repository. Chances are if you have experienced people on your team, they have set up their repository already. But it's good for you to know anyway, or maybe you end up being the person setting it up on your team. And then we'll go over, like, when you make changes, how do you record them, how do you share them, and then how to collaborate and basically get everyone's code to work together. Okay, so that's the plan for today. Normally I stop and ask if there's all kinds of questions, but we are pressed for time. If we finish early, then we'll do questions, but for now I'm just going to blaze through it. Also, real quick, Andre, if anyone sends a message on Discord, can you, like, flail at me? Cool. Cool. All right. So, going into it, why do we use Git? One of the main reasons is to keep code safe. If it's only on your computer, it basically doesn't exist. If it's on your computer and like 2 or 3 others, then you're good. Additionally, Git can help you track history. So you're making changes very quickly. You have a team, a whole bunch of people are doing stuff. If you need to track, wait, when did this change and why did it change? Git can help you do that. It's also easy to undo mistakes. If you committed some bad code, you can just revert that commit. That never happened. It's also easy to experiment. If you want to try something but you're afraid of breaking things, you can basically make a separate version of the project, experiment. If it works, you can merge it back in. If it doesn't work, you can throw it away. And it won't affect your existing code. Okay, so we're going to cover a bit of how to do that. So that's kind of just the Git technology, not to be confused with GitHub, the website and service, which is a separate thing, but it is built around Git. GitHub is a website that makes it easy to share code. So if you're working on projects together, you can do that. It also makes it easy to review team members' code. So you can submit code, people can review it, and then only after reviewing it, they can decide to merge the code into the project. So this is how you can ensure quality among your team. Or if you've made some assumptions about how some systems work, and the person who built that system was like, wait, it doesn't work that way, you need to change this, you can change it before merging your code and breaking everything. You can also automate deployment. That's a little bit more advanced thing, but GitHub has a tool called GitHub Actions, which allows you to, when code is pushed or merged or whatever, do something. So it could be running your tests, it could be deploying automatically. I believe tomorrow we have a workshop on Intro to Vercel, which is for deploying front ends. You could use that with GitHub, for example. So yeah. So how does Git work? Because if you don't understand how Git works, you're not going to know how to use it or how to work in GitHub. So this is what's called a commit graph, okay? A Git graph, whatever you, I'm not actually exactly sure of the name. But there's a few key terms you should know. First is a repository. A repository roughly correlates to a project, okay? Now, maybe your project could have separate repositories. You might have a front-end repository and a back-end repository, or it might all be in one repository. That's up to you guys. This whole image represents one repository. Each of those circles is something called a commit. A commit is when you commit your code, you commit it to history. You basically create a checkpoint of, here are changes I've made, and I'm saving it to the history of the project, the history of the repository, okay? Usually these are read from left to right, or from top down, depending on, or it just kind of depends on who made the graph. Okay, so each circle is a commit. The lines between them suggest a lineage between commits, right? So Git tracks history. History is one event happening after another. Okay, so that's what the lines come in. Now, are you going to draw this ever? Probably not. But it's helpful to visualize so that you understand what it is. Now you'll notice that the line between commits, sometimes it forks and sometimes it merges, okay? This is, each time it splits apart, each split is called a branch. So the green line, that's considered the master branch. That's one line of history. These days we call it a main branch instead because master has some historical unhappiness to it. And then the blue one is one branch, the orange one is another branch. A branch represents a separate path of history. Okay, so you can make your commits to that branch, and they won't affect the main line unless you merge it back into the main branch. Okay? And you can make a branch of a branch of a branch of a branch, but usually you don't do that, it gets too messy. Okay? Now, with a branch, you do not have to merge it. I mentioned earlier you can do experiments. If the work in your branch is not good, you can just delete the branch. Okay? Now, usually in a project, anytime you make a new feature, granted there's many different ways to do this, but a common way is anytime you make a new feature, you make a branch, you work on that feature. When that feature is complete, then you request to merge it back into the main line. This is common practice. Your team may do differently. Talk with your team. Figure out how they want to do it. Okay? Next up is remotes. Remotes are a remote copy, basically a copy that's not on your computer, a remote copy of the repository. So you have a copy of the whole repository on your computer. Your teammates will also have copies. Most importantly, though, if you're doing your project on GitHub, GitHub has a remote copy. And you use that as kind of like the main copy, and all of you sync with that. Okay? So when you add a remote, GitHub is the remote. Now, you may not need to worry about this for your project. If you do it the way that we're going to do it, you don't need to worry about it. If you're doing it kind of manually, you will need to worry about it, but that is not in scope. You can read about that, though. Remote is the keyword you want to search for. And lastly is tags. We're really not going to cover tags today. Tags are for doing like release versions. Like this is version 1.0.0 or something like that. The reason you use tags, each commit, each of those circles, how do you identify one of those? There's a commit hash, but it's not meaningful. It doesn't tell you anything. However, a tag, you can give an arbitrary name to a commit. So you can say this commit is Beej's best commit or something like that, right? Now, usually you only use tags for version tracking. So, okay, commit, 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 commit. None of these commits matter. Oh, this commit, this is version 1.0.0. And then you would apply that tag. Okay? All right, so moving forward. We're going to do a little bit of hands-on stuff. In a normal workshop, I'd ask you to follow along. We could do it together if you run into any issues and all that kind of stuff. But ain't nobody got time for that today. So we're going to work on setting up our own repository together. Okay? So there's a workflow, and we're going to cover it here. Again, I'm going to share these slides, and I'm going to share the video so you can use this as a reference. So if you are worried about remembering every little bit, don't worry about it. It will be on the interwebs. Okay? So what we're going to do now is, oh, this is going to be awkward. Okay. I'm going to pop over to GitHub, and I'm going to walk you through this, but first I'll describe it. So the easiest way to set up a new repository is to start it in GitHub if you are new to all this stuff. What you do is you go to the GitHub website. There's a nice green button that says New. That's for creating a new repository, among other things, but for our purposes, a repository. There's a bunch of options, like do you want to README? Do you want to Git ignore? We'll cover that in a second. You can also choose a license, which is important for legal things, especially if you continue your project after the hackathon. That may be important. And then you can click Create Repository, and then congratulations, you've made a Git repository. But it's only on GitHub. That doesn't really help you because you're not writing your code on GitHub. You're writing it on your computer. But we're not quite ready to put it on your computer. After that, you'll want to make sure to add collaborators. Give other people on your team permissions to write to this repository because by default, you don't want everyone on the internet changing your code. Adding collaborators gives you can give permissions to people to change the code. Okay, so let's walk through that together now. So this is my GitHub homepage. Okay, on the left here is that big green New button. So you would click that, and it allows you to create a new repository. Most of the stuff you don't need to worry about. You may not see this owner thing. I have to do owner because I'm a part of a bunch of different groups. So I check myself, and then you want to give it a repository name. So we could say Seoul Tech Impact. I can't see what I'm writing here. Hackathon Demo 2023 or something like that, right? Hopefully your name will be much shorter. You can give an optional description. Public and private, probably want to do public. Doesn't really matter. Well, no, it does matter a lot. Private means no one else on the internet can see your project unless you give them permissions. Public means that anyone can view your code. Considering that this is social impact stuff, it's probably good to make it open source, in which case you would want to do public. Now, you'll also want to add a README file. The README file basically acts as just kind of an introduction to the project. This is helpful for your team members. Ideally, in the README, you should have instructions on how to set up the project, how to run the project, any configuration that's needed, these kinds of things. Usually, you want to check that. Now, the README doesn't include that by default. It just creates the file where you can put that information. Okay? Then you want to do a git ignore. Git ignore is a special file that the Git software recognizes. In the git ignore file, on each line, you can put a file name or like a file path part to specify, hey, Git, don't put these files into the repository. For example, even if you create a private repository, you should consider it public. It is on the internet in terms of like safety and security. So you don't want to put your database password in there, right? Or any other passwords in there, right? But you need them in some sort of configuration file so your project can see it. In that case, you would, make your configuration file with your secret information, but then add the name of that file that you don't want to be in there into this .gitignore. Okay? Big, big important thing there. Don't publish your secrets on the internet. Okay? So it also, you can choose a different technology. So let's say we're doing our project in Python. You can type Python, and there's a standard set of files that are created when working on a Python project. And this will create a git ignore that just ignores the files that you don't care about, right? So for example, compiled versions of Python files, right? Or compiled modules, right? You don't want that in source control. It's machine code. That doesn't go in source control. This will automatically add those to the ignore list, okay? Then, lastly is choosing a license. There's a whole bunch of different licenses. It is a little bit complicated. But my personal recommendation is if you want no liability, so someone can't blame you if the software breaks, and you want to allow anyone to use it for any purpose, commercial or nonprofit or whatever, you can choose MIT. That's a good one. If you want to reserve it only for open source projects, you can look at, I think, either Apache or GNU, but you should read about these. They have these learn more links here that you can read about them. And I do recommend taking at least a little bit of time to do that. Okay? So anyway, once you've decided on all these options, we're halfway through now, you create repository. Yeah, go away. Yeah. Okay, so now I've created a Git repository on GitHub. Okay? like we just talked about. So now you have a repository. It has our git ignore and it has our readme. I forgot to check a license, but if you selected a license, it would also have a license file. Okay? You never need to touch the license file. Well, you need to edit it to put like who has the copyright, but that's it. Other than that, you don't need to worry about it. So once you've done that, you want to add your team members. So you'll want to click settings over here, and then collaborators on the left, and then you can add people. Okay? Very simple. So you could say, oh, I want to add Summer to my project, this kind of thing. And then Summer can read and write from the project. There are various different sets of permissions. Let's see, what's J? Do I have J on here? I don't have J. Okay, I'm just going to pick a random person on the internet. No, I don't want to add them yet. Anyway, after you add them, you can set permissions. You can look up the permissions on your own. It's not too complicated. I just don't have it here in front of me. So once you've done that, you've created the repository, you've added your team members, now you guys can work together on stuff. But for a moment, back to the presentation. So now that you have your repository in GitHub, how do you get it on your computer? I'm going to show you two ways to do it. One way is using VS Code, because a lot of people are using VS Code these days. And the other way is just doing it directly on the terminal. I will show you both. Okay? So we're going to open up VS Code. Okay, so I have kind of a blank VS Code here. And then on the left, you see this thing that kind of looks like the Git graph that we saw earlier. This is the source control tab. Now, quick disclaimer, I don't keep track of what I have and have not installed in VS Code. This might be a plugin. I think it's default, but it might be a plugin. If it is a plugin, just look up Git. You can just go to your package manager, your extensions down here, and just search for Git or whatever, and you can find it. But anyway, you should see some icon like this, and then you can just click Clone Repository. Now, you're going to get this pop-up here. You just say Clone from GitHub, and then I have like 100 repositories or some stupid stuff because I have no chill. But you should see the most recent project at the top. So we can hear Seoul Tech Impact Hackathon Demo 2023. I can pick that. I can choose where I want to put it. Where's my Linux projects folder? Here we go. So now note that you want to choose the parent folder, okay? Because when it clones it, cloning is basically getting a copy of the repository and copying it to your local computer. It's going to create a folder with the name of the project, okay? So if I choose my general projects folder, it'll create a folder called Seoul Tech Impact Hackathon 2023, okay? So I'm just going to choose my projects folder here. It does a little bit of work. Would you like to open the cloned repository? Yes. And there we go. Yes, I trust the authors because I made it. There we go. And lastly, you want to make any changes to the git ignore if you need. And then you can also edit the README. Cool? Now, one big caveat. If you're on Windows, Git is not installed by default. You might need to go install Git before this will work. Okay? To do that, you can just basically just search Git download on the internet. Whoa, what the hell? No. There we go. You can search Git download. And you'll see this Git SCM website. That's where you can download Git. Okay? So just to recap, you click the source icon, you click clone repository, clone from GitHub. One thing that we skipped, it will ask you to log in. It'll open a browser window, and then you'll log into GitHub. We didn't see that on mine because I did this last night and already logged in. Then it's going to show you your list of repositories. You're going to select the one that you made. And then you choose a folder to put the repository, like we showed up with that thing that came up. And then you edit your git ignore as needed. All good? All right. So I'm going to show you the other way now. If you are not using VS Code, and your most integrated development environments will have some way to do what we just did in VS Code. Okay? Most have that, because pretty much everyone uses Git these days. But if for some reason you do not have that, I'm going to show you the way you do it manually. Again, this assumes that you have Git installed already. Okay? So what you want to do is you want to go to GitHub and go to your project. Okay, and you see this big green button that says code. Okay. You click that, and then you're going to get this little pop-up here. If you're a beginner, basically if you're in this workshop, you're going to want to use HTTPS. The other stuff takes extra effort to configure. We're not going to cover that. You can just click this copy button here, okay? And then you can open up your terminal. If you're on Windows, it's command prompt. If you're on Mac, it's called terminal. And then you can just do git clone paste, enter, done. And then if you want to kind of show the project, you can just do explorer dot. And then it'll open it in Explorer, okay? And then you can, oh wait, right. So then that opens the parent directory, so now I have to go find, what is it, Seoul Tech Impact, there it is, okay? All good? Cool. Yeah. So, now, good, we got 10 minutes left. So making changes. So that's how you get the repository on your computer. So now you have the code, but how do you like do stuff with it? There's a workflow. This is basically the workflow, okay? Ideally you make a branch, you add your changes, you commit your changes. Remember those circles? Those are commits. You add your changes first because maybe you have multiple files or maybe you want to include some files and not some other files, this kind of stuff. Then once you've committed, you want to push to the GitHub remote, okay? You need to push your changes to GitHub so other people can get them from GitHub. Or if you need to get updates that someone else has made, you can do a pull to pull the changes from GitHub and put them on your local copy. And then git checkout, we'll cover that. That's branch stuff, okay? But going over to details, like I mentioned earlier, you probably want to make a branch for the feature you're working on, so that if things don't work out, you can just throw it away. If they do work out, you can merge it and have people review it. Now, you want to also check status to make sure you have everything. There's a couple of ways to do this. In VS Code, I can make this change to a file and save it, right? And then in the source control pane, if I click refresh, it will show me what changes have been made. And then I can say, I want to add this to my change list. So this is now a staged change. It is staged to be included in the commit, okay? Alternatively, in terminal, I can say git add, and I can say either readme.md to add that file individually, or if I just want to add all of the changes, I can do git add -A, and that'll just add everything that has changed. Okay? And, sorry, I can do git status. Again, you see the git status on the left, kind of, but if you don't have VS Code, you can just type git status, and then you can see it in text. Okay, so you have two options. Either one works, they do the same thing. Now, once you're to a point where you're like, I want to commit, well, the question is, when do you want to commit? Ideally, early and often, okay? Because if your computer blows up and you committed and pushed your code, it doesn't matter if your computer blows up. You can go borrow someone else's computer. You can borrow mine. I don't care. The important part is that your code is saved somewhere else, okay? Generally, every time you complete a thought or complete a task, like maybe you're writing a particularly difficult function, maybe you're writing a class, or any kind of general change, you should commit after that. Because if you have a problem, you just want to revert, basically undo a single commit. And so if you do a whole bunch of changes in one commit, it's hard to pull stuff apart. Whereas if you make a commit for every decent sized change, you can be like, oh, I just need to revert this commit, problem's gone, okay? The workflow for this: do your work, add your changes, stage your changes, commit, work, add, commit, work, add, commit. Additionally, you could, if you're paranoid, push after every commit, if you're on your own branch, okay? Or you can push at the end. Either's fine. It depends on how risk averse you are. And then you want to create a PR, a pull request, which we'll cover in a minute, okay? Once you've done all that, your pull request is ready. You let your teammates know, hey, my code is ready to merge. Please check it, okay? So let's go through that workflow briefly. So I'm going to make a new branch. Oh, I actually don't know how to do that in VS Code. Oh boy, here we go. Is this it? Nope, no, that's not it at all. That was a mistake. Nope, 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 nope. Hey, there we go. So in VS Code, I can say branch, create branch, and I can say feature slash Beej's awesome new feature. And now if I do a git, you'll notice in the git status down here, it says origin main. If I type git status again, it says on branch feature Beej's awesome new feature, okay? So now I already staged the change, so I don't need to do that again. I can say git commit made, oh, sorry, why am I on Windows? What? No. All right, anyway, gross. No, I should say on Windows because you guys won't have WSL set up. 1 second, make this go away. So there we go. Okay. So now, if I type, let's clear this. Okay. So I have my README change modified there. It's green, so it's staged for change. It's going to be included in the next commit. I can do git commit -m to include a message, and I can say added new awesome change, end quote, and I can hit enter. But I'm not going to hit enter because I want to show you the other way. The other way to do it is you just, make sure it's added here. You say, this is my new awesome change, and hit commit. Done. Okay? So now I made a commit in my branch. And then I can say pull push. I can say push. The branch has no remote branch. Would you like to publish this branch? Basically, GitHub doesn't know about this new branch I created. I just created this branch on my computer. So it's like, hey, do you want to create this branch in GitHub? And I want to say yes. So now it's publishing the branch. Would you like Visual Studio? Yes, I would like it to periodically run git fetch. That's great. So I don't have to type it. It just does it for me. So now, if I go back to GitHub, now I refresh my page here. Okay. If I click here, I can see feature Beej's awesome new feature. That's the branch I made. Okay? So far, so good? All right, we've got 3 minutes left. We've got to go fast. All right. So the last bit is I made my changes. I have all my changes in my branch. I'm ready to merge my branches into the main project. I have finished my task. What do I do next? Now, in GitHub, if you recently pushed to a branch, you'll get this message, which is very convenient. It's asking if you want to create a pull request. What is a pull request? A pull request is a request for whoever manages the project to pull the changes from your branch into the main branch. It's basically requesting to merge. Okay? So you can click compare and pull request, and then you want to say, I changed the README to talk about how awesome I am, right? Or something like that. Okay? You want to include as much info in here as possible to describe the change because this adds history. So if you need to go back and understand what happened and why, this is helpful. You click create pull request, and then it creates this, okay? Now you want to grab this link and you want to share it with your team because from here, your team can review your changes. How? You click this files changed, and then it shows you what changed and how and where and all that kind of stuff, okay? So far, so good? So now your team members can check your code, and you can also have a conversation so they can leave comments and stuff like that, all right, so you can get feedback. And then whenever you're ready, you can merge the pull request, and that will automatically merge the changes from that branch into the main line, the main branch, the master branch. So I can say this is my new awesome change, merging, done. And then I can optionally delete the old branch. Since I'm making a branch per feature, I can just delete the old branch because the feature's done. I don't care about it anymore. So I can delete branch. And there you go. So now, if we go back to our project and we look at the commits, we can see my awesome new change, which is the commit I made on my branch, and then they make a new commit when they merge branches. Okay? So there we go. That's how you make your changes, add them to Git, commit them, push them to GitHub, and then request that they be merged from your branch. So there is a whole bunch of other stuff that we did not cover today. There's git fetch, git pull, git diff, git stash, git reset, revert, bisect, grep, rebase. You might not need to know all of that. And that's okay. A lot of people only know like 4 or 5 git commands. That's enough to get the job done. But if you want to learn more, this is stuff you can look up. So again, good job. Thank you, everyone. We covered why we use Git, why we use GitHub, mostly for collaboration. We went over a bit how Git works, repositories, branches, all this kind of stuff. We set up a repository. We showed how to make changes, and then we showed kind of the process for collaboration. So we are exactly on time, surprisingly. So thank you very much. And if you have questions, ask your team. But thank you, guys. So good luck, and do awesome in the hackathon. Bye, Internet. Oh, also additional resources in the presentation. I'll share this online. Thanks, guys. Bye.